So my name is Maarten Verkoppen. I joined Mclean about 4 months ago, and we figured this is a good opportunity to kind of give an update on what we're working on, what the latest is, and where we're going. So um, with that, let's get going. So for the people who might not be as familiar with Mclean, we are a Canadian company. We're actually Canada's largest mining OEM. Were founded in 1973 by Don McLean. This is a picture of him working on rigs in his barn to help customers with whatever they needed. And that still carries over to today, except that it's on a larger scale. So we now have about 900 employees all over the world, and we got over 2,000 rigs commissioned. All of our engineering is still in-house. We still do a lot of the manufacturing in-house as well. And we have, for the size of our company, a pretty significant inventory of spare parts. So it's that's sort of where we stand. And we kind of pride ourselves in providing solutions for the underground hard rock market, and ranging from something that we can produce in large numbers to one-offs as well. So that's basically Mclean in a nutshell. As you would expect, we operate primarily in our own backyard in Canada, though we have locations in. We just opened up a branch in Elko, Nevada, South America, Australia, and then particularly our Africa branch has been very successful over the last couple of years in expanding the business. And so our center of gravity is starting to move a little bit across the border, which is good. And we've been growing quite a bit. So part of the expansion is that we also now have our own test facility in Sudbury. So that's a couple hours north of Toronto, and it's a decline that we can use for our own internal testing, which is great. You kind of, for a company our size, you kind of need a facility like that to work on your product development. Sorry, and so we're happy to have this and run our tests. So what do? We basically have three different product lines. They range from utility vehicles, so boom trucks, etc., personal carriers, scissor decks. We have a ground support line, so we got our famous platform bolter, a shock rig line, so sprayers, mixers, transmixers, and then our ore flow suite. So basically anything from a block holder, secondary ore reduction, I think is the technical term, to water cannons, rock breakers, scalers, that all falls in this category. And what kind of goes over top of all three of those product lines is our advanced vehicle technology. The way we see it, we got our three sort of verticals that touch on all of our products, from automation. So this entails the lightest sight remotes all the way up to tele-remote and beyond. Then we got our digital systems, so that's our telemetry, but also our virtual reality training modules that we're coming up with. And so we just completed our Bolter virtual reality training kit, and also the interfaces with the operator on the machine. There's a lot of work that can be done there. And then the one that we'll focus on a little bit more is the electric vehicles, which spans across all three product lines. We believe that ultimately, whatever the future might look like, we know it's going to look different than it is today. And we believe that all three of these verticals will kind of help us move into the next generation of mining, and whatever that looks like with a pragmatic view. Yeah, we're quite keen on moving there. Like I said, whatever that might look like. So when it comes to electric equipment, we started off with our first unit in 2016. It was a bolter that went to Musselwhite, and then Borden started in 2017 with 6 units. That turned into 15. We sold our first unit into Sudbury. That kind of expanded out to Voices Bay. Then we sold a couple in Thompson. Kid Creek came along in Timmins, and we just completed a successful trial in at New Afton in BC. So what we're kind of seeing is that this network effect, where wherever we go, the good news tends to spread. The other good news and problem at the same time is that, for example, the unit that went to New Afton is our demo unit. We're seeing quite often that our demo units tend to stay at that site and that they're sold instead of moving around to different sites. So that's a really good problem to have, because we just need to keep building our demo units, I suppose. So we're now with 9 different mine sites. We got probably close to 50,000 operating hours since we launched, and we're just aching to get across the border now, to be honest. There's a lot of interest from various companies, and we're keen to move forward with this. You'll probably won't be able to hear the sound, but this is the boom truck coming up from the portal at New Afton. It was quite successful. The speed up the ramp was actually quite a bit higher than what they were used to with their diesel unit. And at an average 17% incline, they were able to drive up the ramp empty at 14 kilometers an hour, which drew down the battery of about just over half. I mean, granted, it is a longer haul. So they were quite happy with it, and I think anecdotally the time saved on their way up the ramp was about 20 minutes compared to the diesel unit. So if you do these trips often enough, it will add up, and that's something we've seen quite a bit with our customers. Oh, next slide. So the majority of our fleet right now is between 3.5 to 1.5 years old. And what we're seeing for battery degradation with the batteries that we have is that we see a 2 to 5% degradation over that time period of about just over 3 years. We follow the battery manufacturer's recommendations that the battery should typically be retired at 20% degradation. So I'm sure you can't quite extrapolate, but seeing these numbers makes us feel quite confident that these batteries should last for a good amount of time. There's a bit of a difference between types of machines. Bolters are typically a little bit easier on the battery because they don't draw down as frequently, whereas with boom trucks you see that a bit more often. So that's where you see some of the differences. In our view, what's nice about using utility vehicles is typically, you go down the ramp loaded, so you can use that potential energy from gravity and put it in the battery to a large extent. And then when you unload, you go back up empty. That's a typical way of how machines operate. And so that makes it for a good case. And then on top of that, in case of a boom truck, for example, if you spend 15-20 minutes unloading, then that's a good opportunity to plug in while you're doing that and top up the battery. Every little bit helps. Our batteries don't have a memory, as do most chemistries. Most of the more advanced chemistries, as far as I know. So that makes it for a pretty good application. In terms of what our basic design looks like, this would be sort of a common carrier. This black box here is the battery. We got our onboard chargers, so you can basically plug in anywhere where you have a jumbo plug, essentially. and they can be adjusted for the voltage that you're looking at. Then we got our power electronics. They sit around here. And yeah, essentially we took the electric or the diesel drivetrain out and replaced it with an electric motor. And then we have a little drop box here, or low transfer case, and that's how it works. It also has a brake resistor, so that means that when you're at full capacity of the battery and you're still going down ramp, you can burn off the energy through the brake resistor and create heat. Typically, you don't want to see that because that's a waste of energy, really. But that's ideally you want to use that energy to store in the battery, obviously. There we go. On the vehicle, the way it works, at least in our case, is that we got a continuous monitoring system by the battery monitoring system. So that system just records all sorts of data on the battery. So voltages, ambient temperatures, voltage imbalances, etc. Now, if there are any deviations in what we expect to see, then those faults get reported up to the vehicle monitoring system. That vehicle monitoring system translates itself into an operator interface on the unit, and that allows to warn the operator if there's an issue, or even provide some feedback to the operator on how to better operate the machine. Depending on the and so the same goes for technicians. This screen also has the ability to kind of self-diagnose in a way, and we're continuously expanding on it to help the technician pinpoint what the problem is for speedier troubleshooting. For the off vehicle, so this is when the battery comes off the vehicle. Typically, the battery stays in our vehicles, but when you do have to transport it for whatever reason, you want to make sure that you still keep an eye on the battery. So we developed this little Pelican case that simulates a vehicle management system that we can store with the battery or ship with the battery to provide that continuous monitoring. Should there be an issue with one of the trays that's in the battery box, then we also have fireproof safety containers that you can take the tray out of. You can put it in that box, and that way you can safely ship it or put it on a cage, for example, to get it out of the mine. I think one of the key things really is this whole view on data availability and using that data for risk mitigation. One of the things that we've experienced is that if there's an issue, you get a lot of heads up. There's a lot that you can learn from the data. And so since we already have a lot of experience with this data, we've been able to set our thresholds a little bit better. The nice thing too is that when there's a fault that's detected on the vehicle, this data basically can be transmitted to our portal. And depending on the severity of the fault, that triggers a whole response mechanism within our company, so that a lot of people are notified right away, so that we can remotely troubleshoot it and make sure that the customer is also aware, like the data is shared. Sometimes what we've seen is that we're seeing that data sometimes a little quicker than the customer because the customer might be working on other stuff. But nonetheless, there's an extra set of eyes on it, and this provides one of the best risk mitigations to battery safety concerns. Is that early detection and data availability. The one thing that I will kind of caution, especially mine operators about, is that this link here between the mine, the underground mine, and the worldwide portal, sort of on the internet, this can take quite a while to set up properly. Obviously, there are some concerns about cybersecurity, typically, that you'll want to make sure that there's enough time to make sure that that's sorted out ahead of time. That's for this slide. So the next things that are coming up are our new shotcrete sprayer. So this is the SX3, and it's currently in the factory, the first version, and it will be tested a little bit later at our test facility. It's primarily an EV unit, an electric vehicle, though we'll have it available in diesel version as well. And it's got a lot of really cool features. Aside from the electric part of it, we're looking to also have continuous thickness monitoring and a lot of features to make sure that you don't need spotters to back up the transmitters into the sprayer. One of the cool things, I think, is also that you can use this as a concrete pumper truck. So basically, these are the latest additions to our EV fleet. And then on top of that, I think just in general, there's no such thing as a one size fits all. So right now we offer one battery and one battery only, with possibly some variations. But we're testing same type of battery chemistry and product from a different supplier to augment our offering, so we can right size the onboard capacity for the application that the customer needs. So a case in point is that, for example, a scissor lift typically doesn't trend very far. When it's working, it might already be plugged in, or it moves very slowly. And so having a large battery on board is just a bit of a waste of capacity in a lot of cases. Whereas a boom truck, for example, traveling up a very long ramp, might be short on capacity. And so that's what we'll be offering at the start of next year, after we're done with some internal testing. And then we also have different versions of our onboard charging, just with different capacities available. And so in order to make sense of all of this, I see this as part of my role. We're more than happy to work with you to kind of figure out what's the best size, to provide static modeling based on our operating experience, and find a solution that could work. So those are some of the key things that are new and exciting within Mclean. And thanks for your time. Hopefully this was a useful little overview of what we're up to.
Thanks very much, Martin. Throughout the presentation, there was quite a few questions that came in. I think it's a sign of a good presentation where sometimes the question is asked and then right away you provide the answer in the presentation. So some of them you may have to respond to individually. The next presentation is slated to start in 3 minutes, so I think it'd be good to have one question. I'll pick one out, but one was, how long is the time that it takes to charge batteries empty to full by onboard charger? Or is there any need for a separate fast charger? That's from Jenny Rekola from Sandvik.
That's a good question. So it kind of depends on the charger capacity. So if you charge our battery from 20% to 90%, which is sort of the operating range that we recommend, it would take approximately 45 minutes with our larger onboard charger. What we ideally like to see is that you'll never be in a situation where you have to stop your operation because of charging, but rather see how we can fit it into the operating cycle, using regeneration and possibly opportunity charging when you're loading, unloading, or whatever the circumstances. But about 45 minutes is be the right range.